Hello, this is Todd Frazee, and this is the final assembly project for the course. And please keep in mind you have to the very last day of the class to submit this. So if you feel overwhelmed with assembly, you can keep moving forward with the CAM portions and work with this in parallel. There's a lot of components on here, and make sure you've done all the sub-assembly assignments prior to this assignment, or you won't be able to put this together. So what we're going to do is we're going to bring together all the other components for the model, and there are a few other components that you may need to model, like the springs that we may not be able to download. So here we go. We're going to start and bring in the first components. Now, typically I might start with the base. The Dash 24 is our first model. Let's look at the drawing. We've got a base, and then we have the center structure. And we'll be bringing in the sub-assemblies of the cylinder, drive assemblies, and the Dash 12 assembly. The fit between the sheet metal and the plate and the base isn't all that critical to the function of the design. So I'm actually going to start with what everything else pretty much amounts to, and it's these two center plates, the Dash 1 and the Dash 2, and build up from there. So let's go back to Fusion 360, and we're going to make a new file, assembly, and we're going to abbreviate assembly by ASSY. So it's the entire thing. Let's put a dash there. Okay, save. Okay, here we go. We're going to, we've saved it off as TCOSE assembly, and we're going to open up our data panel, and we'll go ahead and start with part number 1. And then we will accept its current location, and the first component, again, we have to ground it. So after the first component is grounded, we're going to pull in the Dash 2, which interfaces with it. And the slot features should be facing each other in the two components. And we should have our countersunk holes on the outside. So we'll select OK. And we'll create our first joint. It should be a rigid joint between the center of the one arc and the corresponding arc on the opposite part. And we'll get a rigid joint between the two. Okay, the next component we're going to bring in is the sheet metal part, the Dash 3. So we'll bring in the Dash 3 part, and in this case we're going to have two instances of the Dash 3. So we'll go ahead and hit OK on the first one. We'll right click on the component, and we're going to copy, click into empty space, right click, and we're going to paste. Drag your duplicate over to the other side of the part, and let's reverse its direction by 180 degrees so that it is facing the direction we'd want it to. Now the next step, we're going to use another rigid joint, and we're going to go between the center of one of the drilled holes and its corresponding hole on the Dash 1 part. And that'll lock that in and locate it where it would bolt together. We're going to repeat this procedure on the second instance of the Dash 3 part and one of the holes on the Dash 2 part. Alright, so we now have built the framework that pretty much everything else is going to mount to. Let's now bring in our -5, which is a bushing. And we need 2 instances of this part as well. So we're going to turn the first one 90 degrees. Select OK. Right click on the component on the tree. And we're going to do copy. Click in white space. Right click in white space again. And we're going to paste and bring in our second instance. And this component, we're going to flip it 180 degrees from the last orientation. And then select OK. Now again, we're going to have another rigid joint. These things aren't really moving. They should be pressed into the sheet metal. So we're going to pick up on the center of the flange by selecting on the inside radius of the boss, and then the corresponding hole in the sheet metal. And we have one more location, so we'll repeat that same procedure. Joint between the circle of the boss and the outside of the hole. Alright, so we have our bushings. We're now ready to bring in one of the sub-assemblies. So the sub-assembly I'm going to bring in next is the drive assembly. So you should have the drive assembly already put together, and it has a bunch of components on it. So we can bring the drive assembly in, and as you can see, all the components related to it are there. Go OK, and we are going to do a Revolute joint, and the Revolute joint allows it to spin in one axis. So we select Revolute, select the edge I have shown on the drive shaft, and then the corresponding edge on the right bushing that's in the here. And that will make a relationship that it has to be mated to that circle at those faces, and that it can revolve. And so you have your whole entire assembly moved into there. It's all mated with rigid mates, but we should be able to grab onto the wheel or one of the pins and rotate the wheel around if you've done this properly. Okay, so we've got a Revolute relationship. Alright, next we're going to move up and we're going to place the reverser valve, which is your -12 assembly. So let's go down and let's find our TCOSE-12 assembly, bring it in. -12 assembly mounts on the face of the -2 part that has the 4 holes up here. So the slots in this correspond with 2 of them, and when you pivot it, it lines up with the other 2, and it reverses the direction. So we need to rotate the orientation 90 degrees so that we have our sub-assembly oriented close to where we want it. And then we're going to select OK. Now we're going to use a Revolute joint on this one as well. So we'll go to joint, capture position, and we want the edge of the pin so that our snap point goes to the face. And then we select where that pivot point is, which is this larger hole in the center of pattern of 5. Alright, we have our crazy preview, and we're going to hit OK. Now the reverser valve is really only designed to rotate a certain amount. You could put a limit on it, but the Revolute allows it to spin all the way around. There really isn't anything in the, we could put a limit in it, but mechanically there isn't a limit on the design. Now I notice there is an issue with the design here. Our flathead screws will not go in because they're covered up by our reverser valve. So in reality you would have to assemble it with all those fasteners in place before you install this component. We're working in a virtual world, so we're just going to keep rolling. In fact, why don't we go ahead and put those screws in, and that way we've got them done. We're going to end up putting some other components in that will most likely cover those up. So we'll go to McMaster Car, and we're going to select our screws. So to do so, we're going to go to Insert, McMaster Car, and we're looking for screws. Got all kinds of screws. It's a flathead screw that we're looking for, and according to the parts list we have 6 M3 by 6 countersunk screws, so I believe those go in there. So we need a thread size that's metric of M3, and we'll go with stainless steel since we've been going with that with most of the other components. 3/16, and our length of screw is 6 millimeters, and the head type is flat, and we're going to go with slotted like is in the drawing, and it looks like it's only available and fully threaded. So we've got down to one item. They're $10 for 100. We're going to go to the product page and scroll down and download the 3D SAT file. Hit save. And it looks like it throws all these components right on the origin. So there's our first instance of the screw, and we need 6 of them. And they're actually going to face opposite of our current view. So rotate it 90 degrees, hit OK, and then we're going to duplicate that. We're going to do right click, copy, right click, paste, capture position, a repeat paste, a repeat paste, a repeat paste, and I think we need one more repeat paste. So it's 1, 2, 3, 4, 5, 6 instances. They're all laying on top of each other at the moment. So the next thing to do would be to move them away from each other, so otherwise you can't select on them. Okay, so there's our 6 files, or 6 screws. We're going to go through and do rigid mates on them. So we're going to go to joint, continue. Sorry, we're going to go to joints, capture position. We're going to select, I think, the arc here, and then we will select the bottom of our chamfer. Okay, and that should put our screw recessed down below so it's not going to interfere with anything. Now it looks like it peeks out the other end a little bit. That's fine. So we're going to change it from Revolute to rigid and go OK. So we're going to repeat that now 6 times. Okay, once you have all 6 of your fasteners in place, we're going to then move on to installing the next subassembly. The next subassembly is going to be 2 instances of the TCOSE cylinder assembly. So we'll bring in one. And then we'll right click on the subassembly and we're going to copy it, and then we are going to paste it. So we now have 2 of all of those components ready to go. Okay, so our first assembly, and it pivots around this center hole here. So we will use a joint. We're going to select the cylinder. We're going to do a cylindrical and go ahead and pick the pin and pick the towards the end of the pin. We then select the hole that's going to line up with that component. Select OK. Now the reason I did cylindrical on this one, I think it's easier to assemble this if we use multiple mates. And so what we're going to do is this allows us to slide it back and forth and get it in position. And what we're going to do is we're going to drag this out to the right, and we're going to add a second joint to this. Now Fusion's going to give you a warning. They want you to try to solve everything with single joints, which does a pretty good job. But we're going to go to joint and capture position, and we're going to select the surface of one of the feet of this feature, and we're going to switch our type to planar. Okay, so that means whatever I select next has to be planar at all times to the first selection. And we'll select anywhere on the face. Click out in space. It's going to do a funky simulation. Hit OK. And it'll combine the parameters of those 2 joints and force it to satisfy both of them. So this allows this cylinder to rotate back and forth. Now I just noticed something. We have something incorrect on the subassembly. So I must have directed you to align the rod on this piston incorrectly. It should hook up with this drive. So not the end of the world. We're going to fix it. We're going to pick one of the instances and right click on the subassembly, and we can open the subassembly right here in a different file and make that adjustment. The adjustment that needs to be made is related to the -11 part. So we need to figure out which one of these joints, and I believe it's the cylindrical one, needs to be modified. So we're going to right click on the cylindrical and we're going to edit our joint limits to 0 and 0. When we hit OK, it should return the piston to the 90-degree from where it was before. We need to make sure we hit save, OK, close the subassembly, and this little yellow triangle will show up. Anytime you modify a subassembly or a component subassembly, there is a procedure to update it in the major assembly. As soon as I hit that triangle, it's going to process what changed, and it now turns the rod end on both cylinders for us. Okay. The last joint, we're gonna hit capture position. We're gonna change this one to cylindrical. Pick on the hole in the piston rod, and then pick on the pin, and it'll line up. Alright, so now we have two sets of moving parts connected. So if we spin this motor, this wheel, we are also moving the piston. Actually, it works the other way around. And as you see, the whole housing of the piston assembly, the whole cylinder assembly pivots back and forth, and it actually acts as the valve as it changes the holes it covers, reverses the direction of the pressure of the steam or compressed air. Alright, so you're going to repeat that procedure on the second side. I'm going to go ahead and finish it and edit that portion out, and you shouldn't have to watch that twice. Okay, so we now have both of our piston cylinder assemblies mounted, and we can spin motion with our flywheel, and the pistons will simulate. And we should have our reverser valve can move back and forth. Alright, we're getting there, and we just have a few more components to put in. The next component would be the dash 14. It's a restraining bracket. We'll bring that in. Okay, so our restraining bracket is going to mount over this pair of holes here and over the ends of the cylinder assemblies. So we'll do that with the joint. The capture position. I'm going to select the inside of one of the holes. And we're going to go over to the corresponding hole and face where that bracket would slide in. And it should be right there. Okay. We're actually going to edit that joint, and we're going to make that a Revolute. Oh, it's cylindrical right now. We're going to change it to Revolute. And we're going to see if we can rotate this so we can see another hole. And this is a case where we're going to do a secondary joint. Capture position, we're going to do another Revolute on the inside. Okay, so with two Revolute relationships between these holes, it aligns the bracket. Yeah, it looks like we've got a little bit of a discrepancy because it doesn't quite line up with the notches here. So in the design, the whole pattern for this probably needed to be shifted up. And if we were fabricating this, we might just make the slot a little bit wider. Okay, here we go. We've gotten quite a few components in here. Let's get the last of the custom components that you modeled in here, and then we can finish off with the hardware. So these two holes here, one's an exhaust port and one's a pressure port. So that's where the dash 13 tubes go. So let's drag in the dash 13. And let's move it away from the center. And it's going to mount against the face here, so we'll want to rotate the orientation of the model 90 degrees in relationship to it. And we'll select OK. And then we need a second instance of it. So we're going to right click on it on the tree. And we're going to say copy. Pick out space. Right click. We hit paste. We've got our duplicate. And it needs to face 180 degrees from the other one, the opposite direction. We'll hit OK. Now we're ready to do rigid joints to attach those. So go to joint. We're going to capture position, and this is the lower one in the drawing. Pick the opposite end of the straight section because I think the entire tube is pushed into the hole there up to the bend. Okay, so we're going to select there, and we're going to go back to our -1, and we'll select the top of the hole. Okay, and I want a rigid joint. We'll hit OK. You know, one tube sticking out there one way, and now let's do the opposite one. We're going to select again the edge tangency point here, which puts our snap point 3 millimeters into the tube, and then we go to our top hole. And OK. And we now have the two ports. One feeds pressure in and one exhausts. Now the only custom component left is the base. So we're going to bring in the TCOSE 24. Okay, and we'll move the base down. And we'll do a joint that is rigid, and it's going to be between the top of one of our holes and the bottom of the corresponding hole on the top assembly, and OK. Okay, at this point we're going to bring in the springs. So there's two different size springs, and there's different occurrences of the springs. So we're going to bring in the -15 spring, so it should be called TCOSE -15. And if you don't have these components, go watch the video on how to create coil springs, and it walks you through making them. Okay, again, it throws it by default down by our origin, which is not where we want it. And then we're going to rotate the spring to match the angle at which the fastener it's going to go over is. So we're going to go 90 degrees on this one. We'll hit OK. And this particular spring, we need 2 of them. So we're going to pick on the component, and we're going to copy it. Pick in white space, right click again, and we're going to do a paste. And so now we have a second spring. One goes here, the other one goes on the opposite side. Select OK. We're going to create a joint. Okay, and we're going to capture the position, and we're going to keep that with a rigid joint. And we're going to pick up on the center of our coil spring using the sketch that we generated in the coil spring file. And we're going to take and we're going to look at the bottom of the counter bore, and we're going to align our spring with the center of the bottom of the counter bore. Now by default it flipped it around backwards, so we're going to do flip direction, and it puts our spring in proper location. We'll hit OK. Now let's move over to the opposite side. We're going to again repeat the procedure with a joint. picking up on the center point of the sketch circle we had, and then we're going to turn over the model to the so we can view the bottom of the counter bore and select the center of it, and we get our spring. Alright. Now we have the spring that goes on the large stud up here on top on the reverser valve. And that should be the dash 17 spring. Okay, we're going to go ahead and again rotate it so that it's as if it was going to slide on the part. So we need to go 90 degrees. Select OK. In this case we only have one spring, so there's nothing to copy. Then we'll do a joint from the center point to, we're going to use the edge of the hole that the pin's going in. Alright, that should align it. Okay, that's about the end of the tutorial. We're going to leave the rest of the fasteners to you to challenge you to see if you can find the appropriate fasteners. To complete this assignment, you need 6 wood screws going into the base. You're also going to need the hardware that goes through the holes to bolt this together. So there should be a screw and then a nut on the other side that turns it into a bolt. And we're missing a nut on the end of this particular piece, and you need to find a nut that will fit the ends of the 2 studs coming out of the cylinder blocks. Okay, and to get full credit, you got to have all the components there. It looks like to me the whole spacing from center to center, the way we've developed the sheet metal, has worked out as 24 millimeters. If you like, you can go into your base and adjust the width between the rows of pilot holes in there to print at 28 millimeters. So we have a cumulative error of 2 millimeters somewhere there, either between the drawing or the components we modeled. That's it for this project, and remember, you have to the very end of the semester to finish this, and if you're not able to get all the mechanics to work like is shown, that's okay, but what's important is you get every component represented and properly assembled together, and you'll get full credit for the project. It's worth quite a few points. Alright, thanks a lot, and hope this was helpful, and see you on the next one.